I'm Dr. Patty Ferris. I'm a board-certified dermatologist, and I am your host for this episode of Skincare Confidential. I'm delighted today to welcome my good friend and colleague, Dr. Zoe Draelos. Just to tell you a little bit about Zoe, she's a research and clinical board-certified dermatologist. She's in solo private practice in High Point, North Carolina. And in 1988, she founded Dermatology Consulting Services to initiate and perform research in the cosmetic, OTC drug, and pharmaceutical arena. She received the prestigious Maison de Navarre Award from the Society of Cosmetic Chemists for her contribution to the art and science of cosmetics in 2017. I did not know that. Congratulations, Zoe. And in 2019, she was the inaugural recipient of the Florence Wall Award from the Society of Cosmetic Chemists, honoring her as the most influential woman in cosmetic science. Zoe, welcome, and I am so impressed. That's awesome.
Thanks for having me, Patty.
I'm super excited to have you. So I'm going to start this podcast with a bold statement. I think if I stopped 100 dermatologists at the American Academy of Dermatology meeting, and I asked them, if you're going to go hear somebody talk about topical skincare or cosmeceuticals, who are you going to go listen to? 100 of them would say Zoe Draelos. Now, I might be on the podium with you.
I was going to say,
my name would not be the name that came out of their mouth, okay? So Zoe is, if anybody out there does not know Zoe, she is known as, we call you the cosmeceutical queen, but she's known as really one of the most healed and knowledgeable people in the entire area of topical skincare. And it really comes, I think, because of your interest in this arena. It also comes because of your research experience, and we're going to talk about all of that. But I want to start, Zoe, by just hearing a little bit about you and how did you end up in dermatology and how did you end up into topical skincare way before anybody else was in it? And also, how did you get into research?
Those are great questions. And Patty, if I'm on the podium, you're right there with me.
We tend to do a dog and pony show for sure.
We are a good team. So, I did not intend to be a dermatologist. My undergraduate training was actually mechanical engineering. And I ended up doing my undergraduate thesis in a biomedical engineering area, but there was no biomedical engineering at that time. So as I moved through my engineering curriculum, I realized that I'm really a people person, and I decided I liked the medicine a little bit better than the engineering. So I decided to pursue a career in medicine, and I was going to be a pediatric cardiologist because, there's fluid flow in engineering, and there's fluid flow in the heart, and I decided I was going to be a cardiologist. And so I had been doing research at that time in pediatric cardiology. And one day, one of the mentors said, well, we're just going to have to go tell the parents that, the baby's not leaving the hospital. And that was one of those life-changing moments. This is not something that I could see myself flourishing in because that was a very difficult conversation for me. So by this time, I was in medical school, already had arranged a pediatric cardiology fellowship and all this kind of stuff. And I thought, oh no, I have made a huge mistake. I just don't think I'm doctor material. I need to go back and work on cars and be a mechanical engineer again. And so I thought, well, I'm 3 years into medical school. Gosh, what have I done? So then I did OBGYN. I absolutely hated that. Delivering dead babies was not my cup of tea. Then I did radiology. I didn't like sitting in the basement in the dark all day. I thought, oh no, now here I am. I'm about 3/4 of the way through third year, right? I should be thinking what I'm going to become. I thought, oh my word, I don't know what I'm going to be. Well, my next rotation was dermatology. And I was like, wow, this is me. This is my personality. This is happy medicine. This is results you can see. This is young people, old people. This is hair, skin, and nails. This fits right into my cosmetology background. And I decided to become a dermatologist, but I decided too late. I actually missed the match. And so I had to get my position as a leftover position outside the match.
Wow.
Yeah.
Well, that's an interesting story. I knew you had a degree in biomedical engineering because I've heard you use that sometimes when we're in consulting situations, when we're talking about packaging and things like that. That's a unique aspect that you definitely bring to the table. I know you do a lot of skincare studies, and you also have served as a consultant for lots of skincare companies. And a lot of people ask me, how do you get into doing that? And you were really doing it way, before most people were. So kind of talk about that evolution of your career as well.
Well, actually, the way I got into research was sort of interesting. So I had decided that I couldn't go into academics and have a family at the same time. So I left and went into practice. I wanted to have some children, wanted to really raise I have 2 boys. So I had been in practice for about a month, and I get a call. Can we come see you? This is John from Upjohn. I said, okay, sure. I figured they were a drug rep, so they came to see me. And this is the time when Rogaine was being developed, Patty, as an RX drug. And so 2 research scientists came down from Upjohn and said to me, we want you to write the brochures for the pharmacists for Rogaine, and we want to get you started in doing research. And I thought, research? Me, I'm in practice. I'm not sure. And they said, oh yes, you need to do that. So I worked on that project, kind of on the side, and then 3 months later, I get a call from Glaxo. They used to be in the Research Triangle area of North Carolina, and they said to me, we want to come down and talk to you about hair loss. And that was the dutasteride drug, the sister drug to finasteride that was never commercialized, but I worked on that. And then I got a call from Albert Kligman. Albert said, Zoe, you need to come up and see me in Skin. That was his research lab. We need to get you set up in research. And so Albert gave me my first photography setup from Canfield, and he gave me a grant to start up my research lab.
Wow.
And that was how it all started.
Yeah. Oh, that's so interesting. So I know you do so many clinical trials, especially in cosmetics and skincare. And one of the things that I think a lot of times people will criticize topical skincare is that the scientific rigor maybe is not what they're used to when it comes to pharmaceutical studies. And you and I well know that because we present this data all the time. But talk about, putting together a cosmetic study and, what sort of parameters and what sort of things do you like to look at? Maybe talk a little bit about instrumentation too, because I think that's important. But, how do you design these studies, Zoe, like in your sleep, you design these studies. I'm like, where does she get, and they're always the studies that we're presenting on the podium. So, and I feel like the scientific rigor has gotten better over the years. I don't know what you think about it, but I think the companies are very interested in putting the money into good studies. So maybe your perspective on that would be very, I think, interesting to the audience.
Sure. Well, people are always saying you need to have placebo-controlled double-blind studies. And so let's say we're studying a cleanser. Okay, we want to look at this new cleanser and see if it's suitable for people, for example, with rosacea. Well, what's a placebo cleanser? You can't make a placebo cleanser, and you can't tell people, okay, this group's going to use our study cleanser for rosacea people, and this other group with rosacea, they can't use a cleanser. Well, that in and of itself is a perturbation, right? It's not the ethos of a placebo-controlled study. And then, we always talk about vehicle-controlled studies. Well, do you give one person the cleanser with the cleanser and the other person you leave the surfactant out so it's just thickened water? You can't do that either.
Yeah, you can't.
People not wash their face for 12 weeks. So the problem is in drugs, you can test the vehicle versus the vehicle plus the active. Or orally, you can test a placebo pill, right? Mm-hmm. Versus an oral antibiotic, for example. But you can't do that in the cosmetic realm. So you have to have a surrogate. And that surrogate could be the market leader you're going to test against, a competitor. Right. That surrogate could be a widely marketed product that's similar, or it could be use historical controls where people come in, their rosacea looks like X, they use the cleanser, and then when they finish, their face looks like Y, and then you determine if the difference between X and Y is statistically significant. Right. So cosmetic studies just don't always lend themselves to this double-blind, placebo-controlled model that we look for in pharmaceuticals.
Yeah, and that makes total sense. Talk a little bit about consulting, because you've done a lot of that. And again, that's something I get asked a lot by especially younger dermatologists. How did you get into consulting with cosmetic companies?
Well, I think the first thing you need to do is you really need to practice and master dermatology, read all your textbooks. Don't rely on the internet as a source of knowledge. Read books cover to cover. So, my first experience was my clinical experience. And that is very valuable because you can't be a consultant unless you've mastered the whole field of dermatology. Maybe your interest is cosmetic dermatology, but I think you have to master it all. So I think establishing a knowledge base that you own and can put together and synthesize new ideas from, that is your working knowledge base. You can't look everything up in a book. It's got to be up here, because only that way can you synthesize and come up with new ideas. And so I would encourage people to first master clinical dermatology and then think about doing consulting and going into research, because you have to have that practical knowledge base to really offer worthwhile ideas as a consultant. What do you think, Patty?
Well, I agree with you. The companies want to know how we use things in practice. When they come to us, they want to know what are the unmet needs in our practice. So those are some of the common things that they're looking for, which we have to rely on our, at my point, 35 years of clinical experience. I think
Exactly.
you're probably right behind me. But, and the other piece of the puzzle that I think sometimes is missing now, because we've got so much emphasis on social media, is publishing and podium time. They love to have people who have podium presence, because when they're finally coming out with new products, and you and I have been in rooms enough with research scientists and like from cosmetic companies to see that a lot of the things that we recommend actually become products that end up on a shelf.
Right.
And then those products can be talked about because we understand where they came from and why certain ingredients were put in. So I think there's a lot of clinical acumen, as you point out, as well as sort of academic creds that you might want to get that would help you, I think, become part of the group that's maybe in the consulting arena. And I've loved consulting, and I know you have too. We've done a lot of it together, which is probably how we met a bazillion years ago, sitting in some boardroom somewhere. How do you balance your clinical practice with your research facility? Because you're a super busy research facility. And how many clinical trials do you run at any one time? I know you have multiple studies going.
Yes, I think one thing is you can't do full-time clinical and you can't do full-time research. It just doesn't work. So I would say that I spend the majority of my professional time in research, but I do some clinical as well because I enjoy that so much. And one of the things is I don't think you can see clinic patients while you're doing research, and you can't do research while you're seeing clinic patients. And the reason is clinic patients demand you stay on schedule. Research is research, right? You're doing it for the first time. By the time you actually get it down, the study's over. So it's very hard to time clinical patients mixed in with research patients. And then you're always in a hurry, so you don't take the time to look, to see, to score the clinical patients properly. And many people delegate the observational part of clinical research to either their PA or a nurse or a clinical research coordinator, and that has to be the dermatologist. You have to do your own research. It's not like signing off at the end and saying, yes, I agree. You really have to be hands-on, because if you're not, when you're asked questions, you can't answer them. You can't answer to the sponsor, why did this happen, or what went wrong here, or what was the issue.
Right.
And I think that's a mistake a lot of people think, is that I'll just do a little clinical research on the side and maybe just do an hour a week and work it into my clinic schedule. It doesn't work. And then you have to have separate space. I started out with like 500 square feet of research space, did a little bit. Then we went to 1,000 square feet. Research takes space because you have to have the freezers, you have to have the centrifuges, you have to have the storage capabilities to keep the product temperature controlled. You have to have the record storage space. So now we have 33,000 square feet.
How many?
So 33,000 square feet of research space.
Oh my gosh.
And we use all of it,
I'm sure you
for
do.
various reasons. So it takes space. So you don't you don't just dabble in research a little bit.
Right.
You have to make a financial commitment if you're really serious about it, to have the resources to do a good job.
What kinds of things, talk a little bit about, I know you've got a lot of interesting assays and things that you can run. And I know as your space has gotten bigger, you probably have even greater capability in that regards. I mean, what are you doing in that 33,000 square feet is what I'm asking you.
Well, one of the things that we've put in there, because we wanted to bring more science to the world of cosmetics, Patty.
Skincares. Mm-hmm.
And so what we did is we have a full analytical lab. So we have an ELISA machine, we have a mass spectrometer, we have a high pressure liquid chromatography machine. And what we're doing with these machines are looking at, for example, active ingredient penetration into the skin. Like, for example, let's say you have a product and that product has vitamin C in it. And you want to know if that vitamin C gets to where it's supposed to go, right? Because the
Right.
antioxidant isn't supposed to function on the skin surface. If you
Right.
really want antioxidant skin benefits, it's got to get into the viable skin. Well, how do you know if it's there? So one thing that you can do is you can take tape strips,
Tape stripping,
and then
yes.
you know what the footprint of vitamin C looks like molecularly. So then you take those tape strips, you run them through your liquid chromatography mass spectrometry system, and you can actually see what the metabolite breakdown products are. You can see how much vitamin C is there. And then by looking at the various layers of tape strips, you can get an understanding as to what's present at each level in the skin. And so we're doing that not only for drugs, but expanding that into the cosmetic realm to really understand vehicle delivery, to understand, does the product reach its desired target? And then furthermore, once it gets there, is it biologically relevant? Because both you and I know that
Yeah.
you're the expert on vitamin C. I mean, you know how rapidly that product breaks
Oh,
down.
yes.
And many times it breaks down in the bottle before it even gets to the skin.
Yeah.
So companies need to know that kind of information, and dermatologists need to know that kind of information, and we need to provide that. So I think a lot of science is coming into formulation development now, and that's exciting. That's really exciting.
Yeah, that's, formulation, delivery systems, all of that is so important. That's really fascinating. So you can provide them with a lot of information before they even get into a clinical study.
Right. That we
This
can
is
tell
sort of
them
preclinical work.
exactly. Have you hit that sweet spot for stability of your product, aesthetics that the consumer likes, and affordability?
Right.
Does the product meet your price point that you're looking to sell it at?
Yeah, that's so interesting. And also talk a little bit about some, in terms of the clinical studies, after you design clinical studies, like what kinds of instrumentation would somebody need to have? I know you have pretty much everything, but what are sort of the gold standard of things that you want to be able to assay for a skincare product study?
Sure. Well, I'm a gadget person, so I love all those.
I love the gadgets too.
But one of the things you look at is skin pH, for example. You don't
Right.
want something that's going to alkalinize
Alkalinize
the
it.
skin or acidify it.
Yep.
The other thing is that you want to have some measure of skin color, looking for worsening erythema, or if it's a pigmentation product, you want to look for melanin changes. So that would be a colorimeter. You want to look at transepidermal water loss, which is the amount of water coming out of the skin. So you want a transepidermal water loss meter. You might want to look for skin elasticity. That would be a suction cup device. You could also look for skin moisturization, water in the skin,
Mm-hmm.
and that would be a corneometer. So there's a whole science of skin biomechanics and skin bioengineering. And these devices, I should mention, are not approved by the FDA. There's a lot of user variability
Right.
and tremendous variability from time point to time point based on the ambient humidity. That can really affect the amount of water in the skin, because remember, the skin kind of reaches an equilibrium with the environment, whether it's very
Right.
humid, whether it's very dry. And so these devices are not used for medical purposes. They're strictly used for claim substantiation in the skincare world.
Right. Do you have to control the environment in the facility?
Absolutely.
I thought
Yes,
so.
you do. We have 20 air conditioning units, and we have to be able to control the temperature and humidity of each space. And we have to be able to accommodate for changes as a door opens and closes. And we have to isolate the people. They have to sit in a controlled environment for 30 minutes before any measurements can be done. And then the measurements have to be done in a room where you have very, very high outflow of air, and you can maintain a consistent humidity and temperature for the duration of the study. So yes, you have to have a pretty sophisticated HVAC system that is zoned and that can control each room at a different temperature.
Yeah, that makes total sense, because you're measuring Tool and all these things, skin hydration. That's interesting. Do you do any in vitro work in terms of things like looking at biomarkers or epiderm studies, anything, any of that sort of preclinical in vitro work?
Yes, we do. Some of that work, like for example, the ELISA work, we can identify interleukin 17A, we can identify tumor necrosis factor alpha, and those are operative in psoriasis. So you can look to see if a topical agent, for example, decreases those inflammatory mediators. That's more in vivo work, but you can
Mm-hmm.
do that. The skin explant work that a lot of people are doing, I'm not real fond of that because there's no stratum corneum there. And that's
Right.
the most important structure in skincare, right?
Right.
You're looking at that's what's smooth and soft. That's
Yeah.
what's radiant.
It's
So
a
that,
little slice of epidermis and dermis, but not stratum corneum.
well, a lot of this, Patty, is actually cultured skin where they actually grow the skin in a petri
Interesting.
dish. Now,
We
explant
hear them
skin,
report this data all the time, and you never
oh
really know. Yeah,
yeah,
because
yeah.
it's very popular.
And some of it's abdominoplasty skin, fresh
Right.
abdominoplasty skin
Ex
that they
vivo
use,
skin.
ex vivo skin. And that's used like for Franz cell analysis, where you're looking to see how much drug penetrates through the skin and gets in
Right.
the collecting
Right.
fluid at the base of the Franz cell. But if you think about it, that doesn't even apply to dermatology. But that's how all of our drug delivery for topicals is tested. And the reason it doesn't really apply is you don't want to know what gets through the skin, right, into the collecting fluid. You want to know what stays in the skin.
Right.
But that's the best we have, and that's how they're tested. But it's not really clinically relevant
It's not the
because if
best of
the
all
drug gets through
worlds.
the skin, you're measuring systemic levels. And why would you use a topical?
No,
If you want
you
systemic
wouldn't.
level, it do zero.
Exactly.
Yeah.
Well, you test some nutraceuticals as well. You've done nutraceutical
Yes.
studies, I know. And those studies, obviously, that's a whole different sort of setup for testing a nutraceutical. But I know you've looked at some of the collagen supplements and things like that.
But we still use those same bioengineering tools
Oh
because we're
yeah,
still, doing tool corneometry because you're hoping
right.
that somehow that nutritional supplement will provide some enhanced skin benefit, either appearance or performance wise. Yeah.
So just because I would never get this opportunity to ask you this question, what do you think is the next big thing in topical skincare? What do you see really coming down the pike that you find really interesting?
Well, I think personalization of skincare from a technology standpoint, I'm not talking about wearing blue eyeshadow because that's your color and
Right.
personalizing it that way. But, each of us have lots of growth factors that our body manufactures all the time. It's just they may not be where we want to put them, or they might not be in the concentration that we want where we want to put them. So I really see this genetic engineering as being very, very big, whereby you biobank your cells when you're young. You keep them at a -80 freezer, and then when you're older, you're going to take out those cells and either do an infusion of those cells. This isn't technically possible yet, but do an infusion of those cells such that you would give yourself back stem cells, right? That would rejuvenate you. Or alternatively, you would take those cells, you would thaw them, you would culture them, they would produce growth factors, and then you'd use a cosmetic with your own growth factors. So instead of using some that are bioidentical or they came from some other organism, you'd be using your own. So I really think this idea of making donations to banks when you're young and then using that when you're older. I kind of like when I told my kids, when they run around and hit each other, tell them, you better save that energy because you're going to need it when you're older. That same kind of thought, like make a donation of your young cells that you can
I would
then.
love to have my young skin back. I'd love to have, it reminds me of a girlfriend we were talking about PRP. She said, I don't want my PRP. I want my kids' PRP.
Right, right,
And I
exactly.
said, no kidding. We probably don't
That's
have a growth factor between us.
It's true because that's
It's,
what you want. You want to harvest some of those stem cells. And then, for losing hair, you really want to harvest, some of your stem cells in the hair bulge there so that you can give them back to yourself right when your hair is thinning.
wouldn't that be great? And stop your
Yeah,
hair from turning gray?
biohacking is,
Lovely. Or
it's,
falling out, even better yet. Another thing I find really interesting, and I'm sure you do too, is this whole sort of regenerative medicine thing going on in dermatology and in cosmetics, particularly with exosomes. I mean, it's just exploded in the last 2 years. We weren't even talking about that 2 years ago. And now many, many companies going into exosome
yeah,
research, selling exosomes, putting exosomes into skincare products. So that I think is a whole nother fascinating.
it is. It is. There's just, this bioengineering has really taken off, and I think dermatology is an easy place to assess its viability and efficacy.
Yeah. Absolutely. Well, I'm going to wrap this episode because we could talk for a whole nother hour because we share a love for this subject so much. And I can't thank you enough for sharing your expertise and your years of experience and research. It's been so valuable for us as dermatologists to be able to look at the studies that you've done, Zoe. You know, I've presented them on the podium for so many years. And I do say, I laugh at myself sometimes. And this study was done by Dr. Zoe Draelos, and this study was done by Dr. Zoe Draelos. I'm like, and there are other dermatologists doing good work as well, but you certainly were a pioneer. And for those listening, we hope if you enjoyed this content that you'll like our podcast and follow us. And of course, the Skincare Confidential podcast is an offshoot of our medical meeting, the Science of Skincare Summit, which will be held in Austin, Texas on September 21st through the 23rd. Zoe Draelos will be on the podium. Yay! We're going to get you there this year, Zoe. We are going to get you there. But anyway, we're really excited about having you. So anybody who's interested, check us out at scienceofskincaresummit.com, and registration's open. Thanks again, Zoe, and everybody have a great day.